Local landlord gave me a call, stated one of his tenants had no issues whatsoever so far with her air conditioning this summer, and then all of a sudden she did. Later in the evening yesterday, it started blowing out warm to room temperature. Air temperature in the house just kept going up. We'll stop by, take a look. We have had a lot of pop-up thunderstorms every afternoon, so it may be electrically related. Usually when they just suddenly stop operating, that's what it is. However, that side of town that we're heading to is the older section of town, so we are probably about to go on a Jurassic safari and find a dinosaur. So we'll see what we find and hopefully get them cooling. Don't see any obvious damage. We'll check and see if we have high voltage power. So we do have high voltage. We have no low voltage. It's not being called. It is only a AC, so just a 2-wire hookup. So if our thermostat's not telling it to run, it will not run. Let's do something real quick. This is our contactor, and you don't want to do it necessarily with your finger. Again, I'm a little jaded. I've messed with them all the time, but we'll take our insulated screwdriver and just push this little thing in. And what we see is a compressor is operating, but the fan motor is not. So we'll take a screwdriver and see. Oh yeah, it's well and truly jammed. So we have a faulty fan motor. Bearings are bad. That one keeps. So this guy is an 8 horsepower, 208, 240 volt motor, 1500 RPMs. It is a 42Y frame, which is a little bit strange. Most of the, not necessarily strange, but most condenser fan motors are 48Y, so it's a little bit smaller. May take a little doing finding a motor for it, but we'll run to Supply House and see what we can find. These are little plugs. If I'd have been smart, I would have done it before I mounted the motor, but they go in little surface area holes to prevent water from getting into the motor, but you don't want them on the opposite side of the motor, so if any water does get in, it can drain back out. So we'll pop those in. So this little motor, we only have 3 wires on it. So these are our 2 high voltage wires, essentially our neutral and our hot. In reality, it's a 240 volt motor, so both of them are hot. And then our capacitor wire. And so we will get our capacitor when we're ready, and we'll have our brown starting windings attached to one side, and our neutral attached to the other, that going back to L2, this going to L1. We should be good to go. So again, our brown wire goes to one side of our 7.5 capacitor. Our white wire, our neutral, for intents and purposes, goes to the opposite side. Pull these two guys out. So we will attach our black. If you notice, these existing wires come from opposite sides of the contactor. This one is only energized when the contactor is energized itself. So that will be our black wire for our speed. I'll just borrow this wire to run our neutral over. Which again is still 200 or 120 volts. We're just calling it a neutral. And being that this side of the contactor is a bar essentially, so it's just a straight connection. We can either connect to the top or the bottom. We'll connect to the bottom since it's just a little easier to get to. We just attach that back to the neutral side of our contactor, or capacitor rather. It's a mess of wires we have. Now we will energize this guy and see how it runs. We are operating, doing what we're supposed to. Look at our amperage draw. 1.1 amps is within our range, so we are good to go. Once again, this little guy is alive. It looked like it was made maybe April or May of 1989, but it's been a good one. That was a nice little unit there. It's been doing its job since apparently 1989. So longevity-wise, that was when Trane kind of got their name for "It's hard to stop a train" slogan. It's not really the same anymore, but nothing is. But few differences you probably noticed. The motor itself was mounted upside down with the blades on top instead of mounted to the top of the shroud of the unit with the blades down below. Makes it a little more aggravating to change sometimes because more bolts, more screws, especially when you're dealing with 30 some odd years of rust trying to get the bolts off. Other thing you noticed, the motor itself was a 42Y instead of a 48Y. 48s tend to be what's generally used for residential applications anyway. So we did have to go get a specialty little motor, not too hard to find, but a little more aggravating to get, not something I normally keep with me. Other than that, put it all back together. Wiring wise, as you saw, that particular motor, it was 240 volts, being that we had a contactor and we had our L1 and our L2. We just use our quote-unquote neutral coming off the L2 to one side of our capacitor, our brown wire for our start windings on that motor go to the other side of that capacitor. So we just have our neutral from our motor to our L2 going to one side of the capacitor, start winding going to the other side of the capacitor, and our other high power or high voltage wire going to the L1, and that creates our circuit with our phase shift to get our motor started. All in all, not a bad change out other than the age of it, and we'll run on and see what we can find next.